I'm Luke Seibold from PhyziX, and today we're going to be learning about friction. So friction occurs when you have two objects that are in contact with one another. So let's imagine we have a box that's lying on a flat surface. And if we zoom in on the border between the box and the flat surface, draw this a little bigger, we zoom in on this, we'll actually be able to see the microscopic little bumps in the surface of each of these things. So you might not be able to see these with just your naked eye, but if you were to zoom in, you would see that both surfaces have little bumps on them. And these bumps are going to rub up against one another, causing what is called the frictional force. Okay, let's imagine we have that same box, except this time it's sliding down a ramp. So here we go, we got our little box on a ramp. So there's the box on the ramp. And so first we're going to draw in the force due to gravity, which acts downwards, F, G. And we're also going to have the normal force, which is perpendicular to the surface on which the box is moving, normal force. And so that's going to give us a resultant force that is something like that. Now, we know that there's now another force acting on this box. We just learned about friction. So we're going to draw friction between the two surfaces that have friction with one another. So let's draw that in there as a little green arrow and label it with a little f for friction. Now, because the frictional force is the same as the resultant force, these two are going to cancel each other out, and this is what's known as static friction. Static friction. And this is because static means stationary. So if these two forces are canceling out, then the box will not be moving and the box will therefore be static. So that's why it's called static friction. Now let's imagine that the force due to friction is not as much. It's less than the resultant force. Then, although there will still be friction, it is what's known as dynamic friction. And this is because the resultant force is greater than the frictional force, so the box will still be able to move. The point at which static friction becomes dynamic friction and the box begins to move will be the maximum force needed by the box in order to overcome this static friction. The maximum force of static friction is going to be dependent on two variables. The first variable will be the normal force, so that's the force of the surface that is exerted on the box. Now, the next variable it's going to be dependent on is the coefficient of friction, which is given by the Greek letter mu. Now, the coefficient of friction is defined as the ratio between the maximum force of static friction, and the normal force. And so, depending on what material we have in question, there will be a different amount of frictional force required for the normal force that is exerted on it. So different materials will have different coefficients of friction. So using this vector diagram, I'm actually going to show you a pretty easy shortcut to figure out what the coefficient of friction is. So let's call the angle of this slope theta. Now, if we are to continue this line over here down this way, we will see that this angle is also theta. And we know that this line, this imaginary vector that we have here, will be equal to the normal force because it is equal and opposite. And another thing we know is that this this distance will be the same as the resultant force vector. And so if the resultant force vector is the same as the force of static friction, because the box is stationary right now, we know that this vector would be the force of static friction. So therefore, if the opposite side to this angle is the force of static friction, and the adjacent side to this angle is the normal force, then F over n will actually equal tan theta. Over n will actually equal tan theta. Now, if both tan theta and the coefficient of friction both equal F over n, that means that these two are equivalent as well. So the coefficient of friction is just tan theta. And that's a pretty cool tool that you can use to quickly figure out what the coefficient of friction is. If you know the angle, then you can figure out what the coefficient of friction is by just figuring out what the tan of that angle is, what the tangent of that angle is.